Download this code from codegive.com, link in the description below. OK, let's dive into the frustrating world of Blender's viewport clipping issues and how to mitigate them. This will be a detailed guide covering the problem, its causes, symptoms, debugging techniques, and scripting solutions. We'll include Python code examples to help you adjust clipping values. Understanding Blender's viewport clipping. Blender's viewport uses a concept called view clipping to determine which parts of the scene are rendered in the 3D viewport. This optimization technique helps Blender handle very large scenes without trying to render everything at once, which would be incredibly slow. It establishes a range within which objects are visible. Anything closer than the clip start distance or further than the clip end distance will be clipped, cut off, and not displayed. Why clipping happens? Performance optimization. Rendering everything in a large scene, even if it's incredibly far away, can significantly slow down the viewport. Clipping allows Blender to focus on the area the user is most likely working on. Limited floating point precision. At extremely large distances from the origin, 0, 0, 0, floating point numbers, used to represent 3D coordinates, lose precision. This can lead to rendering artifacts, z-fiding, surfaces flickering because the renderer can't determine which is in front, and generally unstable behavior. Camera positioning and scale. How far your camera is from your scene, and the overall scale of your objects, heavily impacts whether clipping becomes a problem. If you're working on a miniature scene, the default clipping values might be way too large. Conversely, if you're modeling a planet, they're probably too small. Symptoms of clipping problems. Objects disappearing or being cut off. The most obvious sign is parts of your model, or entire objects, simply vanishing from the viewport, especially when you zoom in or out. This is particularly common when dealing with large-scale environments or very small objects. Flickering geometry. As mentioned earlier, z-fiding can occur when objects are very far away. Clipping problems can exacerbate this. Unexpected rendering artifacts. Jagged edges, missing faces, or other visual distortions can appear, especially at extreme zoom levels or distances. Inconsistent behavior. The same object might be visible from one angle but clipped from another, even if it appears to be within the same distance range. Debugging clipping issues. 1. Check the viewport camera clipping. This is the most common and first thing to check. Select the camera in the viewport, even if it's just the default viewport camera. Go to the Object Data Properties tab, the camera icon in the Properties panel. In the Lens section, look for the clipping settings. You'll see start and end values. Adjust the start and end values. Decrease the start value if objects close to the camera are being clipped. Increase the end value if distant objects are being clipped. Important. Make small, incremental adjustments. Very small start values and very large end values can negatively impact performance and potentially introduce precision issues. 2. Check the view properties, End panel. Press the N key in the 3D viewport to open the N panel. Navigate to the View tab. Look for the clip start and clip end values under the View section. These are for the viewport camera, not necessarily your scene's active camera. Modify these values to affect the visibility range in the current viewport. This is generally the quicker solution for temporary adjustments in the viewport itself when not rendering through a camera. 3. Understand the scale of your scene. Are you modeling something microscopic or something astronomical? The default Blender unit is typically considered a meter, but you can change this in the Scene Properties tab, the icon of a scene with a film slate, under Units. Asterisk if your scene is very small, you'll need to significantly reduce the start and end clipping values. If your scene is very large, you'll need to increase them accordingly. Asterisk apply scale asterisk make sure that the scale of your objects is applied, Ctrl+A scale. Non-uniform scale can sometimes cause unexpected clipping behavior. For origin point placement asterisk. Asterisk where your object's origin is located can influence clipping if the object spans a wide distance. If the origin is far away from a significant portion of the mesh, the clipping might be calculated based on the origin's distance, even though most of the object is closer to the camera. Asterisk consider moving the origin of large objects to their center, object-set origin to geometry. 5. Check for very distant objects asterisk. Asterisk sometimes, a stray object or a small particle system located extremely far from the origin can inadvertently force Blender to use very large clipping values, which can negatively affect visibility of closer objects. Select all and then press period on the number pad to focus the view on everything. This can reveal unexpectedly distant objects. Delete them if they're unnecessary. 6. Precision issues with extreme coordinates asterisk. Asterisk if your entire scene is located far from the origin, 0, 0, 0, you might encounter precision issues regardless of clipping settings. Asterisk consider moving your scene closer to the origin. You can do this manually, or using scripting. 7. Using viewport overlays for debugging. Asterisk Blender provides a display bounds option for objects, which can display a box around the object's bounding volume. This can help you visualize the object's spatial extent and check if the bounding box is partially clipped when the object should be visible. To enable it, asterisk select your object. Asterisk in the object properties, go to Viewport Display. Asterisk enable display bounds. Scripting solutions, Python. Here are several Python scripts to help you manage and adjust clipping values programmatically. 1. Setting clipping values for the active camera asterisk. Explanation asterisk. bpy.context.scene gets the current scene. Scene.camera retrieves the active camera in the scene. This is important. It only works if you've designated a camera as the active camera, usually done by selecting it and pressing Ctrl plus numpad 0. If no camera is designated as active, it will return none. Camera.data gets the camera's data block, which holds settings like focal length, sensor size, and clipping values. Camera_data.clip_start and camera_data.clip_end set the desired clipping distances. 2. Setting viewport clipping, for the 3D view. Explanation asterisk. This script iterates through the areas of the current screen, Blender's window. It checks if an area is a view_3D area, a 3D viewport. If it finds a 3D viewport, it accesses its spaces. It iterates through the spaces to find a view_3D space. Space.clip_start and space.clip_end set the viewport clipping values. The return statement ensures that the clipping is only set in the first 3D viewport it finds. This is important if you have multiple 3D viewports open, as you likely want them all to have the same clipping. 3. Automatically adjusting clipping based on scene size asterisk. Explanation asterisk. 1. Bounding box calculation asterisk. The script iterates through all objects in the scene of type mesh. It finds the minimum and maximum x, y, and z coordinates of all vertices in the scene, effectively calculating the bounding box that encompasses all objects. This ensures that even objects with modifiers are accounted for. The evaluated dependency graph is used to get the final mesh data after modifiers have been applied. The try, except block handles cases where evaluating the mesh might fail. It then calls object_eval.to_mesh_clear, to clear the evaluated mesh data and free the memory used by it. 2. Bounding sphere It calculates the center of the bounding box. It calculates a radius based on the maximum dimension of the bounding box. This effectively creates a bounding sphere that encloses the entire scene. 3. Clipping value setting *clip_start is set to a small fraction of the radius. This ensures that objects close to the camera are still visible. The value radius /100.0 is a good starting point but can be adjusted. *clip_end is set to a large multiple of the radius. This ensures that distant objects are also visible. The value radius *100.0 is a good starting point but can be adjusted. A minimum value is ensured for clip_start. 4. Applying to viewport and camera it calls the set_viewport_clipping and set_camera_clipping functions, defined earlier, to apply the calculated clipping values to both the viewport and the active camera. Important considerations for the auto adjustment script performance calculating the bounding box of a very large scene can be computationally expensive. Use this script sparingly, especially if you have a complex scene. Consider caching the bounding box information if you need to run it frequently. Fine-tuning the clip_start and clip_end values are determined by the factors 1/100 and 100. You might need to adjust these factors based on the specific needs of your scene. Empty scenes the script handles empty scenes gracefully by returning early. Hidden objects the script currently considers all mesh objects in the scene, even if they are hidden in the viewport or disabled in renders. If you want to exclude hidden objects, you'll need to add a check for object hide_get, and object hide_render within the loop. Units the script assumes that the Blender unit scale is reasonably set. If you are working with extremely different units, example millimeters for architectural models versus kilometers for landscapes, you'll need to adjust the script accordingly. 4. Moving scene to origin If you're encountering persistent precision issues due to the scene being far from the origin, you can use this script to move everything closer. Explanation * 1. Bounding box calculation same as in the auto clipping script. 2. Center calculation same as in the auto clipping script. 3. Translation vector calculates the vector needed to move the center of the scene to the origin, 0, 0, 0. 4. Object translation iterates through all objects in the scene and adds the translation vector to their locations. This moves the entire scene while preserving the relative positions of the objects. Important considerations for moving the scene animation if you have animated objects, this script will move the objects, but it will not update the animation data. You'll need to manually adjust the animation curves or keyframes to account for the new object positions. Constraints and drivers constraints and drivers that rely on absolute world positions might also need to be updated. External files if your scene uses linked or appended objects from other Blender files, moving the objects in the current scene will not affect the objects in the external files. Origin points be aware that the origin points of the objects will now be different relative to their geometry. This might affect behaviors that depend on the origin point, example rotation around the origin. You might need to adjust the origin points of individual objects if necessary. Best practices for avoiding clipping issues. Plan your scene scale. Think about the scale of your scene before you start modeling. Choose appropriate units and stick to them. Keep objects relatively close to the origin. Avoid placing objects at extremely large coordinate values. If you have a very large scene, consider dividing it into smaller chunks that are closer to the origin. Use the auto clipping script sparingly. Run it only when you notice clipping problems. Don't make it a part of your regular workflow unless absolutely necessary. Monitor clipping values. Keep an eye on the start and end clipping values in the viewport and camera settings. Test frequently. Zoom in and out and move around your scene to check for clipping artifacts as you're working. Consider adaptive clipping, advanced for very complex scenes. You could implement a more sophisticated adaptive clipping algorithm that dynamically adjusts the start and end values based on the camera's position and the distribution of objects in the scene. This is a more advanced topic and might require more complex scripting. In summary, clipping problems are a common annoyance in Blender, but understanding the underlying causes and having the right debugging and scripting tools at your disposal can help you overcome them. Remember to prioritize scene scale, origin point placement, and regular monitoring of clipping values to avoid these issues in the first place. By combining manual adjustments with Python scripting, you can create a more robust and efficient workflow for dealing with large or complex scenes. Remember to apply scale and adjust the origin to geometry. Good luck.